Hey guys, and welcome back to Quantic Academy. So today I'll be teaching you how to actually differentiate. Okay, so let's get straight into it. So let's start off with this. Okay, suppose we have a function f of x is equal to x squared. Now how do we differentiate this? So the general rule of thumb is basically you take the power, right? So here the power is 2. You bring it to the front, okay? So you get 2x, and then you minus 1 from the power. So 2 minus 1, that's 1. And then x to the first power is just x. So I can just write this as 2x. Okay, so the derivative of f of x, and remember we write the derivative of f of x as f prime of x, is equal to 2x. Okay? Pretty simple, Right. Let's do another example. F of x is equal to, let's say, x cubed. Now what? Okay, now do the same thing. Take the power, bring it to the front, minus 1 from the power. So we get f prime of x is equal to, bring the power to the front, so 3 in the front, x, and then minus 1, so the power will be 2. 3x squared. Pretty simple. Okay, now let's try another one. Let's try y is equal to 3x squared. Okay, now how would you differentiate this? Okay, well, firstly, when we differentiate y, we write it as dy dx. Okay, that's the first thing. Next, we actually have to differentiate this. So it's the same thing. Take the power, bring it to the front. But now there's already a number in front, so what do? Well, we just multiply the numbers. So now we get 3 times 2 instead of just 2, because the 3 is already in the front. And then leave the x there, minus 1 from the power. So 3 times 2 is 6. X to the first power is just x. So we just get 6x. So it's pretty straightforward differentiation. Okay. Now let's do some harder ones. What about y is equal to 2x cubed minus 4x squared? How would you differentiate this? Well, this is pretty simple as well. So you differentiate y, you get dy dx. Okay. Now since we have two terms here and a minus sign in between them, we just do it step by step. So we see this 3 here, bring it to the front. So we get 2 times 3 in the front, which is 6 x, and then minus 1 from the power. That's 2. And then do the same thing here. Bring 2 to the front. We already have a 4. Actually, we have a minus 4 because we also have the minus here, don't forget. So minus 4 times 2, that's minus 8 x, and then minus 1 from the power. 2 minus 1 is 1. Okay. So you just get 8x here. So that's it. So if you have add or minus between two terms or more terms, then you just do each term separately. So we just did this term first, and then we did this term later. Just put the sign in there. So let's do another example. Y is equal to 3x squared plus 4x minus 3. Okay. So dy dx is equal to, take the 2 here, bring it to the front. 3 times 2, that's 6. X minus 1 from the power, 1. Okay, now this one, 4x. So x is just x to the first power, right? That's pretty straightforward. So the power here is 1, so we take the 1, bring it to the front. 4 times 1, that's just 4. And then we have x, and then you minus 1 from the power. 1 minus 1 is 0. We have x to the 0th power here. Now, what's x to the 0th power? Well, x to the 0th power is just 1, because anything to the power of 0 is just 1. So here we just have 4. Okay? And now here, I don't know why there's a thing here. Get rid of that. Okay, here we have 3. We just have 3 by itself. Now, 3 is the same thing as 3 times 1. Okay? 1 is x to 0. So if we were to do the same thing, we take the 0, bring it to the front. 3 times 0, that's 0. So the last term is 0. Okay. So we just have 6x plus 4. Now, in general, if you have a function like this, where it's something, let's say some constant times x. Here, m just represents a number. It's a constant. Okay. Then when you differentiate it, this is x to the first power. The 1 comes to the front. 1 times m is just m, and then x, and then you minus 1 for the power is 0. And you have x to the 0th power, that's just 1. So it's m times 1 is just m. So whenever you differentiate something times x, you get back to something. Okay? So if you differentiate 2x, you get back 2. Differentiate 6x, you get back 6. Differentiate 3 billion x, you get back 3 billion. Okay? Now, if you just have a constant, okay, let's say you have some constant number represented by a. A just represents a number. Okay? Now when you differentiate this, what do you get? Well, when we differentiate the constant here, this one we had 3, right? When we differentiate, we got 0, because you have the 0 here, bring it to the front, times everything by 0, it kills it. Now, another way to see this is when you have a function like this, something equals to a number, what is the graph of that? Well, let's look at, for example, the graph of y equals to 1. The graph of y equals to 1 is just a straight line. That's not a straight line, but it's meant to be a straight line. Okay? What about the graph of y is equal to minus 3? Again, straight line. Graph of y equals to 100, straight line, straight horizontal line. Now what's the gradient of each of these lines? 0, exactly, because they're straight horizontal lines. They have no gradient. And since differentiating it just finds the gradient, when we differentiate, we just get 0. So whenever you differentiate a number, you get 0. Whenever you differentiate a number times x, you just get back the number. Okay? So these are some shortcuts you should keep in mind. Okay, now let's do some more stuff. Okay, now for what if you get given a function like this? Now what? Now what do you do? Okay, well, this is still pretty simple. If you have x to the power of something in the denominator, then it just becomes x to the minus that, right? So here we get x to the minus 2. Because the minus here means 1 over x to the power of 2, 1 over x squared. And then we have the 3 on top. So, yeah. And now when we differentiate it, we just do the exact same thing. So take the minus 2, bring it to the front. We get minus 2 times 3, which is minus 6x, and then minus 1 from the power. Minus 2, minus 1, that's minus 3. And again, x to the minus 3 is just 1 over x to the power of 3. So just get this. Simple. Okay? Now, let's do another one. Let's say you have f of x is equal to 2 over x. Okay, let's say you have f of x equals to 2 over root x. How would you differentiate this? Actually, let's make it harder. 2 over x times square root of x. Okay, let's do it step by step. Okay? If you have root x here, that's the same thing as x to the power of a half. That's the definition of x to the power of half. And here, x is just x to the power of 1. Now when you multiply two numbers with the same base, you just add the powers. So you get 1 plus a half, which is 1 and a half, is the same as 3 over 2 as your power. And now this 3 over 2 is in the denominator, so that means it just becomes minus. So when we differentiate, we do the exact same thing. Take the power, bring it to the front. 2 times minus 3 over 2. Well, the 2's cancel out, you just get minus 3. So 2 times negative 1.5 is negative 3. And then x is there, and then we minus 1 from the power. Minus 1.5 minus 1 is minus 2.5. It's the same thing as minus 5 over 2. And so if we were to write it as a fraction, then we will write it as, remember, minus means over. So we write 3 minus 3 over x to the power of 5 over 2. And if they ask you to put in the formula of something times square root of x, well, it's also pretty simple because square root of x is just x to the power of half. So if we do it like this, here, square root of x is x to the power of half. And then when we multiply, we add the power. So 2 plus a half, that's 2 and a half, or 5 over 2. Okay? So you can either leave your answer like this, but if it explicitly says to put it in a certain form, then put it in a certain form. Otherwise, this is okay. Actually, most of the time, even this will be okay. Okay. Now let's do something a bit hard. Let's say you have a function. Let's say you have something y is equal to 2x plus 1 and 5 over x minus 3. Okay. Now this is multiply. How do you differentiate this? Well, there's actually a technique to differentiate this very quickly, but we don't learn that in P1. We learn that in P3. So the only way to differentiate this now would be to firstly expand this. Because you see, we've learned how to differentiate when it's x to the power of something plus x to the power of something else plus x to the power of something else. We haven't done it when it's x to the power of something plus something else plus multiply something. We haven't done this. We haven't done do this. Okay. So first, let's put in a form where we know how to do. So let's expand it. So 2x times 5 over x, that is 10. 2x times minus 3, that's minus 6x. 1 times 5 over x, that's 5 over x. 1 times minus 3, that's minus 3. Okay, now we can simplify this. Oh, sorry, wait, this is not dy dx, my bad. I only expanded it, I didn't differentiate yet. Okay, and so if I simplify this, I get 7. 10 minus 3, 7 minus 6x plus 5 over x, remember, over x, that's the same thing as x to the minus 1. Okay? Now we can differentiate it, because now we know how to differentiate this. Is x to the power of something plus x to the power of something. Okay. Remember when we differentiate a number, we just get 0. Okay? And when we differentiate a number times x, we just get that number back, so minus x. And then now when we differentiate this, take the power, bring it to the front, we get minus 5x, and a minus 1 from the power. Okay, simple as that. This is simplified, so 0 minus 6 is minus 6. X to the negative 2, that's the same thing as 1 over x squared. Okay, and you have the minus 5 here, so put it there. Okay, last but not least, let's do, the syllabus also asks you to differentiate something like this. And so, I'll teach you how to do that. Okay, suppose you have a function y is equal to x squared plus 5x minus 3 over 3 root x. How do you differentiate this? Well, remember what I told you, you have to get it in terms of x to the power of something plus x to the power of something, because we know how to differentiate that. So, let's try and do that. Well, I can split the fractions, right? If I split the fractions, I get 3 individual terms. So, if I split the fractions, it will be like this. Okay. I haven't done anything, I just split the fractions. It's the same thing as that, because when you combine this, you get that. Okay. Now, let me express it in terms of x to the power of something plus x to the power of something plus x to the power of something. Okay. So here, you got 3 in the denominator, that's the same thing as 1/3. Okay, now this is square root of x. This is x to the half. But it's in the denominator, so it's x to the minus a half. Then you got x to the power of 2 here. So if you simplify it, you get x to the power of 2 minus a half, which is the same thing as 3 over 2. Okay, the same thing here, you got 5/3 here. This is x to the power of 1, and this is x to the power of half to the denominator, so you do subtract the powers, 1 minus a half, that's the same thing as a half. Okay, and here the 3's cancel out, so you just get minus, then this one, the root x is in the denominator, so you get x to the negative a half, because it's in the denominator. Okay, now we can actually differentiate this, so let's do that. Dy dx is equal to, take the power, bring it to the front, 3 over 2 times 1/3, the 3 cancels out, so you just get 1/2. X and a minus 1 from the power, and you get a half. The same thing here, 5 over 3 times 1 over 2, you get 5 over 6. X and a minus 1 to the power, you get minus a half. Okay, and last but not least, we just have to differentiate this. Minus a half, bring it to the front. There's a minus here, so you get minus a half, plus a half, x, and then you minus 1 to the power. Minus a half, minus 1, is minus 3 over 2. Checkmate. So, that's it. That's it for today. Thank you guys for watching, and I'll see you all in the next episode.